Hello and welcome class to what I believe is now week 3 of this project management module at the University of Kurdistan, and this is coming to you from quarantine this semester because of the coronavirus. This week in week 3 we're going to be moving on from a project definition. That's what we talked about last week when we discussed project initiation and how you define the scope and what are the correct parameters for quality, cost and time. And now we're going to be looking at project planning this week. And that's associated with how are we going to deliver the project. And this week we're going to be talking specifically about project teams, and with that, how do we form the perfect team for delivering the project. And part of that we will be looking into work breakdown structures and also organizational structures. And probably in the next lecture we're going to be talking about contracts, how you form agreement between the various team members. So let's get underway. So as I said, in this section, today we will be talking about work breakdown structures, or WBS for short. It doesn't stand for a whole lot of bull. It stands for work breakdown structure. Now, part of that is we will also be looking at organizational structures, who reports to who, and those two elements go together into forming your project team. And in the next lecture we'll be talking about contract type. So one of the first things we need to do after we've defined the project scope is we need to make a project work plan. And that usually happens when initially with the project manager beginning to break down the project into small individual units, which we call work packages. Now these little units will be basically trying to break down the project into lots of small projects. And that way, and the way we divide these units or work packages, it's usually done in order. So we know that the design of the infrastructure we know that the design of the foundation, that can only come after the design of the superstructure. So we know how much weight is in the superstructure, so we know what load is going on the foundation. But the design of the foundation can also only occur before the geotechnical study to see what the ground conditions are. And also the foundation construction, that can only happen after the foundation design. And you can see that we're already breaking down the project into various work packages. Now, this is called a work breakdown structure, or a WBS. It's basically a hierarchical decomposition of the work that needs to be executed by the project team. Now, with each work package, you will normally be able to assign a certain amount of money to it, a certain amount of time, and also you can list any key resources that need to be given to that work project. And normally, to track these things, we normally give the work package its own tracking number. Now, that's only for very large projects, but it gets very confusing with very large projects. Normally, a work breakdown structure could have thousands of little work packages. And in order to make sure that the project is delivered in an appropriate time, at an appropriate quality, and at an appropriate schedule, you need to assign time and money to each work package, and you need to monitor if that's going over time, over schedule, or over budget. and you also need to monitor if the quality is at an acceptable standard. Now, normally at a very preliminary stage, even at the project definition stage, the project manager will be making a preliminary work plan and breaking down a very simplified work breakdown structure. And at this stage, the project manager may see that certain work packages are just not feasible to achieve. If there's the design of a very specific cantilever, for example, in one of the work packages, the project manager will realize, you know what, we just don't have the personnel to achieve that work package. And the project manager must be bold and say, because of certain work packages which are just not feasible, the project as a whole is not feasible, and we need to reevaluate the project or change it or scrap it. And the project manager must be bold and courageous in doing that, because sometimes the project manager's job is on the line, but being bold and courageous will save the project a lot of pain further down the line. It's much better to discover that a project is unfeasible at the start than halfway through. So this is a little example of a work breakdown structure, or a WBS. You can it's usually given in a graphical form, so it becomes clear for everyone what is happening. Now, at the very top, you've got the project title. You've also got a little bit of information about the project in terms of what it's trying to achieve, its total budget, its total schedule, how much time can be sent to it, and also maybe who is the overall senior project manager. Now, that project can be broken up into various phases, and we looked at that already when we saw the project life cycle. So let's say we're breaking the project into 3 phases of, I don't know, investigations, design work, and construction. And all of those different phases can be broken up into smaller work packages, and they are descending from underneath each phase. And so with each work package, as a bare minimum, you should be having a good description of what that work package is trying to achieve. What is the goal of that work package? And also, you need to be able to, even at a preliminary stage, assign a budget for it, how much money can be spent on that portion of the work package, and also a schedule, how much time can be spent on that work package. And the final thing is you need to resource that work package. What do we need to achieve this work package? What sort of engineer, what sort of specialist will achieve this work package? Who will be responsible for it? Also, you may want to include what sort of resources do they need for achieving this work package. Is there any amount of equipment or machinery that is required? Do they need software for the design work, or various other things? That is a typical work breakdown structure. Now, this helps you organize your project. And one of the key examples of this would actually be with your 4th year research projects, your capstone projects. Initially, when you were presented with the 4th year capstone project, it seemed quite daunting, didn't it? You weren't sure what you were meant to do. It seemed like an awful lot of work. But then you were able to define what the project is. You did a lot of literature review, and you defined what it is you were able to, what it was you were trying to achieve with the project. The next step would have been to do a work breakdown structure, break down the project into lots of small little packages like this, and decide sort of how much time you were going to spend on each package, and suddenly the capstone project seemed a lot less daunting. So good organized people do a work breakdown structure almost intrinsically without even writing it down, and they're able to achieve a lot more work. They don't waste nearly as much time at the start of every day wondering what I should do. I actually try to do a little bit of a work breakdown structure every week for myself, just so that I'm working efficiently, and I assign hours and to each work package, whether it's preparing a lecture, delivering a lecture, if it's doing lab work or research work or admin work. I break down what it is I'm supposed to achieve each week, and that's not even project related. But with a project where scopes can be hard to define, you've never done it before, it's unique, a work breakdown structure is very important for organizing the project and making it achievable. And the other great thing about a work breakdown structure is when you present it well, it's actually a very good communication tool between each of the project team members. If you've got a different team member in charge of a different deliverable, a different work package, they can see how their work contributes to the overall project work. So that it's a very useful communication tool as well as an organization tool, a work breakdown structure. So this is an actual real-life work breakdown structure that I made probably about 7 years ago when I was working in Oman. I just moved to Oman. And what it was there was a motorway project that was being built out south of Bahraini, close to the empty quarter, way out in the desert. And they had lots of workers working on this project, and they were all from Bangladesh and India and Pakistan, these workers. There were about 500 of them working on this motorway project. And every day they were driving these workers in buses from the nearest town, Bahraini, to the motorway site. And it took about half an hour of driving. And before long, they realized, you know what, we're wasting a lot of time. What we should be doing is building a small accommodation facility so that all of these workers can live close to the work so they can do more work every day. So this was a project I was involved in. I was project managing it, and it was all about establishing the site. Well, the first thing I needed to do was break it down into little phases. So one of the things that I thought of was I'm going to break it down into 3 phases of fitting it out, making sure that all the facilities are acceptable, also clearing the site. So where we were building this, we actually had to clear the site first. It was an old factory site that we had found, and it had some old factory equipment and sheds there. Interestingly, it also had a little bit of asbestos, that cancerous substance. So this was an old building, old facility from the 1970s. And the third phase I needed to do was actually arrange security. A fence needed to go up, there needed to be gates fitted, and also cameras for security. And then with those 3 phases, I broke it down to further work packages. So part of the clearing site was carrying out an asbestos survey, making sure that there was no asbestos on the site. And sure enough, I discovered that actually there was a little bit of asbestos. And that meant that when we came to stripping the site, we actually needed to use some safety equipment so no one inhaled asbestos. We demolished the sheds, we broke them down, and then the final thing was we also had to clear the rubbish, take all the debris away. With the fit out, we had to establish the surface, so that was actually preparing the ground, building a subgrade, and then also we asphalted a large portion of it to create a car park. And then there was the erection of the site accommodation, so we brought in temporary porta cabins or portable living quarters for the workers. And the other work package was down to utilities, making sure there was water, there was electricity. We also got a Wi-Fi connection installed for the workers, and also wastewater. We had to make sure there was going to be no sewage contamination that would have made the men sick. With security, that was broken down into 3 work packages: erecting the fences, fitting the gates, and also installing cameras. So those were the different work packages, and those were just titles, but with each of those little boxes I actually did eventually assign a little bit of a budget for each one, who would be responsible for achieving each project, and also I also gave a schedule, a date when they could start each work package and when they must finish it by. And I also gave this work breakdown structure to everyone in the project, just so that they had a clear understanding of what needed to be achieved. So this is the final project that was delivered. This was in the south of Oman. And what I ended up, the final thing was we were able to build this large accommodation facility on the site for the motorway workers. And so they were living in those sort of porta cabin type houses, and they were comfortable, and it meant that the other project, the motorway project, could be delivered at a faster rate. So this was a little project within a project. And then you had work packages which were similar to little projects making up a big project. It's kind of like Inception. So this is another example of a work breakdown structure. I'm not sure what this project is, but you can see I think it's got some sort of software component to it, because you've got something called systems integration. So I'm guessing they're making a factory or something here. But you can see that they've broken it up into a few different key components. You've got the design work, the engineering work, so I'm guessing that's concept design, and then systematic or final detailed design. You've got construction. You've also got safety. Keep in mind that when you're doing a civil engineering project, you've got to make sure that those who are building the infrastructure stay safe. And so all of those sort of control systems, they actually have their own work packages associated with it. Now, just a couple of notes with this. You will notice that actually with each work package there is a tracking number. So the project is project 1267, and then it's got a series of breakdowns to name each work package. As I said, you need to have a tracking system for very large projects where you can have anywhere up to 1,000 or 2,000 work packages. You need to have a tracking system so that you can easily communicate and you can easily control that there isn't any project scope occurring, or any of the work packages are going for a cost far greater than is necessary for the project, or they're going over schedule. You'll also see here that there's a percentage given for each work package. I'm not sure what that's a percentage of. Maybe it's a budget percentage, or maybe it's even a time percentage for the delivery of the project. Here's another project which is all about, I think it's basically doing some maintenance work on an existing building. So yeah, you've got the project definition stage, and you've got various work packages associated with that. Then the detailed design and tender stage. So it's not just down to construction. You've got construction there, but you need work packages for all phases of the project, from project definition right through to project closure or handover. And so each of these work packages will have a different schedule associated with them, and also a budget associated with them. So remember, with work packages, it's important to determine the schedule for completion, also the budget that you assign for each work package, and also giving details on the quality that needs to be achieved. And this is so that all the work packages put together are achieving the project scope with appropriate cost, time, and quality constraints. You also need to list key resources which are needed to achieve the work package. So if it's construction work in this work package, potentially you might need a digger, maybe you need a roller or a grader, maybe you need software equipment to do the design work, who knows. But you also list who is responsible for delivering the work package, so everyone has a clear idea on what their responsibilities are. Now, that doesn't mean that the person responsible for the work package achieves all of the work package. He's the only one working on that work package. No, he will actually be responsible for bringing other teammates in for achieving the work package work. You may also list certain risks that are associated with the work package. So is there a risk that if the weather is bad, the time taken to achieve this work package will be longer? You may also see potential opportunities where, if this work package is done to a certain high quality, that will mean that other work packages will be done in less time. Maybe. And also, that if a really advanced work package, you would be talking about prerequisites, postrequisites, and co-requisites to the work package. So we have this in the civil engineering program. There is a prerequisite for doing project management, and that is that you've completed engineering economics, because project management builds on engineering economics in several aspects. Likewise, you need to have done statics in order to do the structural engineering modules. Those are prerequisites. You can also have postrequisites, which go in the other direction, and co-requisites, which means this work package, you must be doing it alongside another work package. They've got to be happening simultaneously. Now, initially when you do the work breakdown structure, you're just going to be making nodes with names, but in time you're going to have to fill in the details of those various work packages. So here's an example of certain work packages. Let's say we're building that Einkawa Road 100 meter road intersection that we talked about last week, and I make a work breakdown structure for that, and then I've got to fill in the details of various work packages. Well, here are some of the work packages. I've given you an example of 3 here. You could have the traffic analysis report. So you're basically assessing the key stakeholders, meaning the drivers, and you're basically assessing to see where they are driving to. Where are the bulk of them turning? Are they mostly driving through? And so forth and so forth. Now, who am I putting in charge of that work package? Well, I'm going to be putting Dr. Abbas in charge, Abbas Bakhtiari. He's an expert in traffic. Well, he wouldn't call himself an expert, but he definitely knows a lot more about traffic analysis than I do. But he will need a team involved to help him do the analysis report. So he's got me in the team. He's also got Hamid Ahmed. Hamid Ahmed is a friend of mine. He's a Syrian refugee. He's often looking for work. And so he'll probably be the person doing the survey, counting the number of cars which turn and so forth. And the budget to achieve this is $25,000. That goes towards the software traffic flow that we need to use. It also means that we need to have a budget for paying the salaries for achieving the traffic survey, and also we're given dates. It's got to be between the 9th of September to the 12th of December. It's got to be around that region. Now, look at conceptual options report. Again, this is where we're doing basically an options report, similar to what we talked about before, looking at different concepts for achieving the project aim. Again, there's a lead, someone responsible for the project, and in this case it's me. So even though I'm mentioned in another work package, that doesn't mean I can't be involved in a work package elsewhere inside the project. So typically, usually with any work project, any project you're working on, you could be involved in dozens of different work packages at any given time too. Now, you also have a start date, you've got a completion date. In this one, I've also got a review date, meaning that there's a date for when this work package needs to be reviewed by others. And this comes a little bit later in the project, so it's actually got prerequisites. All of the prerequisites, all the work packages from 126.143 through to 0.147, they need to be completed before this work package can be achieved. So this is one of the good things about having tracking numbers for each of your work packages. It's easy to refer to them and you don't have to write out long titles. And I've also got a little comment here that this is actually an internal document that I'm producing. It's just for the project organization. There's also seismic loading assessment. That's another work package. Who's going to do that? Well, of course, it will be our resident geotechnical engineering expert, Dr. Kamran Pinari. And the resources that he needs are the Geological Survey of Iraq, certain prerequisites 126.1 through to 126.25. Those need to be achieved before he can begin this work package. He's got a budget and he's also got a schedule for achieving that. And one of the great things you can do with a work breakdown structure is print it out on a big piece of paper, and you can have it at your project HQ, and every time a work package is achieved, you can give it a good tick. And once all of those boxes are ticked, you've achieved the project from start to finish. So those are examples of the minimal details that we would have in the work package boxes. So now let's talk about project teams. We're not going to go in that much detail about teams and the dynamics of teamwork. We touched on that in the first lecture with project initiation. But what we need to do now is we need to build a team according to the work breakdown structure. Other than the people involved in the project who make the work breakdown structure, you always form the team after the work breakdown structure. You're looking at the work packages and you're saying, who do we need to achieve these packages? And you're basically going to need to get specialists to find people who are qualified to carry out the individual work packages. You're never going to find someone who can achieve all the work packages, and if you can, it's probably going to be a low quality project because there's been no specialist input. And at the same time, it's very important that everyone in the project team understands how their work, their responsibilities, the work packages that they're achieving fit into the overall project. So they need to have a good understanding of the overall project scope and the goals of the project. So an effective project team, the team members will have a very good understanding of the project scope, the quality, cost and time constraints, what the project's trying to achieve. They need that in order to understand how their work packages fit in with the overall project. If they don't have that, then they're likely to achieve their work package in a way which is deviant from the project scope. They also need to have a clear understanding of what their roles and responsibilities are, not only for their work packages but also other people, so that way they can actually collaborate. If I'm working on my work package and I think I need to actually get someone with good structural engineering knowledge involved in this work package to help me, I can go over to the structural engineer who I know is responsible for many of the work packages which are primarily about structures, and I can get his input. And you also need to have a high degree of trust. If you're the project manager, you can't be watching everyone and making sure they're doing their work packages. You need to be able to trust them that they're going to achieve their work packages and they're not going to hold up the project. So certain barriers to project teams being effective or not. Well, one of the key difficulties is when there's very unclear project objectives and the project scope is unclear as well. So one of the big issues is if you've got a project team which has 100, 200 different people, you could have people at one end of the project building the project at a very high quality, whereas at the other end they're building it at a lower quality, at a lower cost and in quicker time. And there's no point having a very high quality tyre on a very low quality car. There's no point having a very high quality engine inside a very low quality train. Because it doesn't actually add value to the project. So everyone needs to be aligned with the same project scope. You also need to understand each person's roles and responsibilities. Now that comes from a good, clear work breakdown structure with a good, clear description in each work package. If you don't have that, then suddenly you're going to start having project scope creep, where people start moving away from the project scope. Schedules are not kept, budgets are not kept, the quality is not done to a good enough standard. And also it can be down to bad communication Often people complete their work packages, but that's not communicated up the line to the project manager, and so all of the post-requisite work packages that come off it do not start in a timely fashion, and various other things. Also, when a project goes over many years, you will have a turnover of staff. And when there's a high turnover of staff, that can lead to poor communication. New staff members come in and people are unaware that, and those new staff members are not properly orientated to the project. They can be unclear on what their work packages are, what their responsibilities are. They may be unaware of changes in the project that have occurred over time. All of these things can affect the efficiency of a project being delivered. Now here's another thought for you. Everyone in the project team, they are not necessarily working for the same organisation. In fact, they rarely are. You can often have three different organisations involved in a project, centred around the design organisation, the construction organisation, and then the owner of the project, those paying for it, often the government in the case of civil engineering infrastructure. There's also other people involved in a project too, though. You've got people involved in stakeholder liaison, you have environmentalist groups, you have regulating bodies, and all sorts of other people involved in the project. And so this becomes a difficult thing. Often people can become loyal more so to their organisations that employs them and pays their salary rather than the project that they have been seconded into working towards. So now we turn to organisations and the organisational charts. We've made our work breakdown structure. We've determined the people that we need to hire or employ in some capacity for the project. We now need to arrange those people into an organisation so that people are reporting and are accountable to different people. And there's different ways of doing that. Every organisation, every business has an organisational hierarchy. Everyone has middle managers, and those middle managers report to the big boss, and so forth and so forth. But how do we do that with a project? Well, it's not just a cut and paste. There are some key aspects of project management which look a little bit different to business management. We need to make sure that all of the people involved in the project have appropriate authority and appropriate accountability. Now, the first thing that helps with that is actually having project-specific CVs for everyone. So these are CVs which are not telling you the person's every which skill, but they're skills that are specific to the work packages that they're achieving in the project. And then from that, you can place them in project departments where they are placed with similar people who are doing similar work packages, or they could be working with them on the same work packages. Now, those project departments, they could be anything from functional to project-based or matrix-based, and that can be weak, balanced, or strong. We will talk about those different functions in a moment and those different organisational structures and their pros and cons in the coming slides. But keep in mind that as well as there being a senior project manager who is up and above overlooking the entire project, you will have project managers found throughout the organisational structure. You will have project managers in charge of different project phases or in charge of different project departments. And so that's why everyone needs to learn about project management. It's not just a postgraduate course we do in civil engineering. Everyone needs to be exposed to the aspects of project management, because everyone will be a project manager to some degree, even if they don't carry that title. So let's look at an example here. We've got a project where we're working for the Ministry of Electricity, and we will work in the dam department. Now, the Dukan Dam, it needs a new generator and turbine refurbishment. So look at that picture of a hydroelectric dam on the right. You can see that it encompasses civil engineering, mechanical engineering and electrical engineering components and discipline. So you can see there you've got the dam itself, you've got the penstock, the channel that the water travels through, you've got the draft tube where the water spins around the turbine, and then you've got the outlet or the draft tube. All of that is the responsibility of a civil engineer. But the turbine, that's going to be spinning around, and that's connected with a generator. All of those components, they are the responsibility of mechanical engineers. Now, at the generator, that's going to charge the stator, and that is going to charge the transformers, and then you've got power lines. All of that, that's the responsibility of electrical engineers. So how do you structure your project team, keeping in mind that as well as all of the other people, such as quality controllers, regulators, and owner representatives and everything else, even in the pure engineering, you have a division of discipline. You're going to need civil, mechanical, and electrical engineering disciplines in your project team. So one of the most common organisational structures is what we would call a functional organisation. And this is actually how we shape the management at the University of Kurdistan. At the very top you will have a chief executive. So in the case of the University of Kurdistan, that would be Dr. Hajar. He's the university president. And then you've got underneath him, you've got deans of the schools. So the dean of the School of Science and Engineering would be Dr. Sorku. And under him you would have middle managers, and they are the heads of department. The head of civil engineering, Dr. Joseph. The head of petroleum, which is Dr. Safraz. And the head of computer science, I believe that's Dr. Tariq. I can't quite keep up with the computer science department. They go through a lot of change. And then underneath them you've got the minions, you've got the pawns, the people who are reporting to the heads of department. So who's reporting to Dr. Joseph? It's, well, myself, Dr. Kamran, Dr. Dara, Dr. Abbas and Dr. Mahmoud, and Dr. Idris, sorry, he's new here. And so you could have that in an engineering consultancy. You could have the chief manager of the company, and then under them you could have a manager for electrical engineering, a manager for mechanical engineering, and a manager for civil engineering. So if we were going to use this functional organisation for the project that we talked about with the dam, where there's both electrical engineering, mechanical engineering, and civil engineering components to that project, the project coordination, meaning the project management, that will be done by the managers together. The electrical engineering manager, mechanical and civil engineering managers. And then underneath them, they will select certain staff within their departments to work on the project too. They won't use all of the staff because some of the staff are working on other projects. So they will form a team this way. So those who are in red, they're the ones working on the project, and they've selected staff to fit the skills required to achieve the work packages in the work breakdown structure. Now, one of the great advantages of a functional organization is this is typically how most organizations are organized from the get-go. I am used to reporting to Dr. Joseph in my everyday job. So if we're working on a project together, it seems natural that I will continue to report to him. So there's a lot of comfort in this type of project. The difficulty comes, though, in that the managers, they will need to be managers of other projects too, and so they can't fully commit to this project, and that means that this functional organization structure for project management, it only really seems to work for very small projects with a short duration and also a short budget and low risk. For really big projects, you need to start using a matrix structure or projectized organization, which we will get to. Another good advantage with the functional organization is that often when a project comes to an end, you can be left in limbo wondering, what's my next project? Well, this functional organization, it will just keep on operating as your day-to-day job, and you will keep reporting to your manager, and they will just feed you with new projects. So that works well. Now, one of the big issues with a functional organization, though, is who is the project manager? Well, actually, the project management is shared between, in this case, 3 different managers who are department managers. They may not have the key skills needed for project management. We've already talked about the key differences between production management and project management. They're quite different, and project management is considerably more difficult. So there may not be a good understanding of how to manage a project. The other issue is that without one dedicated project manager, before long you end up working in silos. The electrical engineering management team, the mechanical engineering team, and the civil engineering team. And before long, there's very little communication between those 3 parts of the project. And so that can lead to project scope. Generally, engineers, we care a lot about quality. We just have a personal ambition to make sure our infrastructure has high quality. And we may not really appreciate the constraints in terms of cost and time, and so we can tend to make things overly with an overly high quality with an overly high cost and over time. But the other issue is we're not going to be communicating the civil engineer with the mechanical engineer, electrical engineer. That can break down. So let's say in the civil engineering team, we're working to design a very good penstock and a very good draft tube, and the mechanical engineers, they're working to design a very efficient turbine. What happens if there's a lack of communication because they've ended up working in silos? Well, potentially the turbine won't fit with the penstock. The 2 components won't be a good match, and you end up with a lower quality for the overall product, the overall project. The other issue is you can end up becoming more loyal to your functional manager, meaning me to my civil engineering manager or to a mechanical engineering manager. You become more loyal to your organization than you are to the project. Because remember, these managers, they have other projects at various times, and they have split loyalties. They could easily tell you, please stop working on that project for now, I need you to work on another project, and that could be to the detriment of the project. So for these reasons, these advantages and disadvantages, generally we would only do functional organizations with small projects. Oh, one other disadvantage with a functional organization. With a project, usually people are working from different organizations. So that becomes quite difficult, doesn't it? Normally there could be several different companies involved in a project. And so with a functional organization, that can actually break down the lines of authority and responsibility. So the next way to improve on this is to have what's called a weak matrix organization. So in this case, it's exactly the same as a functional organization for the project, but now the project management has been given to one of the managers. In this case, the civil engineering manager. And the mechanical engineering manager and electrical engineering manager, they are no longer involved in the project. There will be people in their teams who are involved in the project, but they are now reporting, as far as the project is concerned, to the civil engineering manager. He's the project manager, and all project coordination is done through people underneath him. Now, here's a little bit of an issue. Suddenly, these people are reporting to managers outside of the project. They may commit to themselves to working 30 hours a week on the project and 10 hours a week on their other responsibilities. But if the mechanical engineering manager speaks to one of the guys in red underneath him and says, actually, I need you to be working 30 hours a week on these other projects, suddenly there's going to be a breakdown in communication. You are reporting to people outside of the project who do not have the same goals of achieving the project at a good cost, time and quality. And you do have many of the same disadvantages that you would have with functional management too, in that there isn't any one project manager, and so you can end up working in silos too, to a degree, not so much as the functional organization. Now, with the balanced matrix organization, this is exactly the same as the weak matrix organization, but now one of you has been given the responsibility to coordinate and be the project manager. Now, this doesn't necessarily have to be one of the department managers. It could be someone underneath. But now the project coordination is done by the project manager, and he may take one or two other people into his project management team for running the project. Now, in this case, the civil engineering manager, he's in red, he's involved in the project. But who's he reporting to? Well, he's actually reporting to the project manager as far as this project is concerned. So even though in the organizational hierarchy he's below the department manager, the civil engineering manager is reporting to him. And this happens a lot in business, where there's not pride and hierarchy and Worcester getting in the way. Often people will work in the universities on research, and the project manager of that research project could have even his boss reporting to him, strangely enough. Now, this does get a little bit complicated too, one of the advantage of having a balanced matrix organization is suddenly you have one dedicated project manager calling the shots, and so the effects of siloing, where people are only thinking about their component, the civil engineering management, the mechanical engineering component or the electrical engineering component, that breaks down somewhat, and people get a better overall view of the project scope, and they are dedicated to achieving the project scope at an appropriate cost, time and quality. Now, there are a couple of small issues with this though. First off, suddenly, if you look at the mechanical engineering staff involved in the project, they don't have a higher up, more senior manager involved in the project. Neither do the electrical engineering managers. Now, this can mean that the quality of various components, be them electrical, mechanical or civil, can diminish. But the cost and the time are better managed, and we'll see this. Functional organization tends to achieve better quality, so long as the components of electrical, mechanical and civil fit well together and there's good communication between the project coordination team. As we move towards a weak balanced or strong matrix, suddenly there's better overall views of the project and how everyone's responsibilities fit in the overall project. But key quality can diminish as there isn't the same access to the senior engineering managers for the reviewing of the work. And then you have a strong matrix organization. This is where you completely change the structure of your business, and rather than there just being 3 departments under the chief executive of electrical engineering management, mechanical engineering management and civil engineering management, you now have a 4th department called the project management team. And you have a department head, the manager of the project management team, and underneath him you have a variety of project managers, and they've all been assigned the management responsibilities of various projects. So with this project, the project manager for the dam project is actually the project manager in red, and he's selected a couple of key staff from within the organization to coordinate the project with him. Now, this is a fantastic way of doing a project, because now the project manager, he's not biased. He's not a mechanical engineer, he's not a civil engineer, he's not an electrical engineer, although he may have an engineering background. He's no longer loyal to one discipline, so he's not going to forsake the mechanical engineering components so that he can give more budget to the civil engineering components, for example. He's very committed to achieving the project scope. Now, where this can become a little bit difficult is for the staff. See all those red staff? Who are they reporting to? Well, in terms of the project, they're reporting to the project manager. But in terms of their everyday work and their departments, they're reporting to their department managers, the electrical, mechanical and civil engineering managers. So what happens when you have 2 bosses? Well, this is a problem with all of the matrix organization structures. You end up getting overworked, and this is one of the key problems that we have with matrix structures, is that yes, staff and particularly engineers can be overworked because they're reporting to 2 bosses, and one boss will assume that you're working full-time for him and the other boss will assume you're working full-time for him, and if there's poor communication you get overworked. That brings staff morale down, that brings dissatisfaction, and that can affect the quality of the project being delivered. So that's an issue with all matrix structures. So you can see with weak, balanced to strong matrix structures, you have the benefit of basically centralizing, as you move along that spectrum, centralizing the project management so that people are not working in silos. Of course, as you do this, it becomes more expensive. Plenty of organizations can't afford to have a whole fourth department for project management. But generally, the larger the project, the more you're going to move towards this strong matrix organization. And the final organizational structure, this is an example of a matrix structure. So you can see you've got the president of engineering at the top, and he's got various departments underneath him. He's got a project management department on the left. He's then got controls. So these are different departments in and of themselves. Planning and scheduling, quality control, and cost estimation. They will all be different departments. And then you've got the engineering department, and underneath that you will have an civil engineer, electrical engineers, mechanical engineers, and so forth. So let's imagine, and you've got different projects that you're reporting to. Now let's just imagine for a second you are this civil engineer. Now you've been seconded in your organization to work on a project, and so you're going to be positioned here. Who are you going to report to? Well, in terms of the project, you're going to be reporting to the project manager on your left. He's in charge of the project. But in terms of your everyday discipline, you will be reporting to your manager. That means that whatever civil engineering work you do, you need to take it to your discipline manager first to approve your work and sign it off. And he may be very slow at doing that because he's outside of the project. He has no understanding on the importance of the schedule or the cost of the project. And so when he reviews your work, he may be slow or lethargic on it, or he may say you need to improve the quality when actually you don't need to for this project in particular. What's more important is that it's low cost and done quickly, for example. And so when you're reporting to two bosses, when those two bosses want something different, you're going to be blamed. It's not a fun position to be in. And so the best solution to all of this is have good communication. And I spent most of my career working in projects where they had a variety of matrix organizational structures in the projects. And so I've spent most of my career reporting to two bosses. The best solution to this is have good communication, and if at all possible, get both bosses communicating with one another, and do what you can to foster that. CC both people into emails. Keep them abreast of the work you're doing. Keep them aware of your time restrictions, how much you're investing into the project, and get those two bosses in agreement for how you are best to be utilized. That's a little tidbit from me. Now the next step with all of this is to go to a projectized organization. In this case, you take the middle managers completely out, the discipline managers of the civil engineering manager, the mechanical engineering manager, electrical engineering manager. You take them completely out, and now you are reporting solely to a project manager. And if you're the civil engineer, you are the civil engineering expert in this multidisciplinary team reporting to a project manager. Now, I have to say that I've done this a couple of times, and it was really great fun. Some of the most enjoyable projects I've worked on have been where I've been part of a multidisciplinary team, because we are all contributing something different to the project, and it's great fun. Everyone is completely committed to the overall project, and they don't have any split loyalties. They're not working on any other projects. They're working full time on this one project, and it's wonderful. Now, a couple of issues with this is that obviously everyone involved in the project needs to be completely full-time in this project, and so it needs to be a pretty big project to justify this. And so, yeah, an example of a project where we did this, it was, I've done this on 3 different occasions in my career, and the project price ranged from 20 million to 120 million US dollars. They tend to only do this with very large projects. And what's cool is actually you often all come from different companies. When I worked on a motorway project, I was actually working for a civil engineering consultancy, and I got seconded to this project. So I moved offices. I moved to a project office, and the mechanical engineers, electrical engineers, we were all employed and paid by different companies, but we were all put in a room together away from our regular jobs, and we were reporting and working together on just the one project, and it was great fun. And having that open office, having an office that was dedicated solely to the project, it meant that we had good communication, and we were able to be completely committed to reaching the project scope. Now, yeah, a couple of downsides with this. One is it can only work with very large projects, because you need to have a large project to justify moving all these people away from their regular day jobs, working on one project solely. The other big issue is that when the project finishes, often the civil engineer, mechanical engineer, electrical engineer, they move back to their companies, and the companies have started moving into a different direction. And so often people lose their jobs when the project finishes. And so that can cause a little bit of anxiety, and it can actually influence people's desire to finish the project in a timely fashion. Now, engineers, if you're a good engineer, you don't need to worry too much about unemployment, maybe a bit more in Kurdistan, but I remember when I was working in these projectized organizations, us, the civil engineers, we were not too worried. We knew if we lost our jobs, there would be another project we could join. We would never be unemployed for more than 1 week. But for other people, such as the accountants or the quality controllers or the quantity surveyors, their jobs were a bit more specific. There isn't quite the same demand for their skills, and so they worried considerably about losing their jobs when the project finished. The other big issue with this project is you've got to make sure there are people with the expertise within that red box who can review your work. So let's say I am the sole civil engineer in my in this project. Who's going to review my work? Who's going to make sure that I've designed everything carefully? Well, I can't take it to the project manager. He knows nothing about civil engineering, nor the mechanical engineers or the electrical engineers. So you've got to make sure that you've got senior engineers for all of the disciplines who can also review work. And so that's why with these projectized organizations, you need a very big project to justify it, because in truth, you're never going to have one civil engineer. You're going to have several civil engineers and mechanical engineers and electrical engineers so that they can review one another's work. So this is just a little bit of a summary with the various projects. So if we look at the left column, a functional organization, there's very little authority given to a project manager, so people can tend to lose their view of the wider project and get bogged down in focusing just in their tiny little pigeonhole of the project. Also, resourcing can be difficult because the people in charge are also trying to resource other projects at the same time. And their role as the project manager is very much part-time. And so that can affect the quality and efficiency of the project. With the matrix, as we move towards a strong matrix, there will be more authority given to a project manager, and more resources will be given, and there will be people who are committed full-time to the project. There's no split loyalties. However, they are reporting to two bosses. And if we go completely to a projectized project organization, there's no split loyalties. However, to justify projectizing an organizational structure, you need a very large project, and I'm talking in the realm of tens of millions. That tends to be how it goes. Now, if the last few slides have been a little unclear to you, I realize it's a little bit hard to picture because many of you have never worked in a professional work setting. But I recommend the last 3-4 slides where we've talked about organizational structures. You listen to this again, even put it on a slower speed so you can understand it a bit more, and also read the portion of the book, Oberlender's Project Management for Engineering and Construction, that I'm putting at the end of this lecture. Read that. I will also put a very small link to a website which I found helpful too when I was researching for this lecture. Now, one of the things that is important with any project, once you've got the team, is you have a kick-off meeting, and we talked about this briefly, but this is where you're making sure everyone is aware what the project scope is in terms of quality, time and cost, and so that they don't get pigeonholed, only involved in their single component of the project. They see how it fits with the entire project. They have a clear understanding on responsibilities, what work packages they should be achieving, their budget and schedule for those work packages. They also have a better understanding of the team structure, what the expectations are for reporting, and also if everyone is in the room together, it gives an opportunity to talk about potential risks and opportunities. So with the example of the dam project, the mechanical engineers could be talking about a certain type of new turbine, and I can speak up, yes, but with that type of turbine, even though it works more efficiently, it will create more eddy currents on the concrete draft tube and the spiral case, and it's going to wear it out quicker. And we can actually balance things out for our various components to achieve the project scope. Another cool thing about a kickoff meeting is we can talk about key performance indicators. How are we going to measure success? When are we going to achieve certain milestones? And finally, we can make sure sometimes we're missing certain stakeholders. So someone can speak up, actually, have you spoken to this person who's downstream? If we use a very noisy turbine, that's going to affect their quality of life. We need to get their permission first, or what have you. So that's the sort of thing that you would have at a kickoff meeting. And it's a great opportunity to give suggestions. So one of the issues often is people feel like their suggestions and views for improvement for an organization are lost. The truth is, I have far more knowledge on how to improve the civil engineering course, especially engineering economics and project management, which is my specialization. I know that far more than Dr. Joseph, and far more than Dr. Sorku, and far more than Dr. Hasia. Why? Because this is my specialization. I'm the frontline soldier. I see the struggles and the difficulties in the module and room for improvement every day. And no disrespect to Joseph, Sorku or Hasia, they're great men, but it's not their specialization. They specialize in other things, and they're not at the coalface. They're not dealing with problems, and so they don't see opportunities or potential problems the same way I do. But they're the ones making the decision. I can't change the civil engineering structure considerably. So if I pass a suggestion up to them, a good manager should actually listen carefully with respect. But often with a functional organization or with a strong hierarchy, you often don't sense that. A kick-off meeting and having a more projectized organizational structure creates better communication and opportunities to give feedback and suggestions for improvement. So that's all we have for today. Supplementary reading. Read pages 101 to 113. I thoroughly recommend this. And it talks about work breakdown structures and organizational structures. The book is available as a PDF on the Moodle page. Thank you and goodbye.